Good morning, everyone. Welcome to the Arthritis program web seminar series. Today is our fifth lecture, and it's on new aspects of gut and joint interactions in arthritis. Today's our speaker is Dr. Georg Schett from Germany. And over to you, Rob, for introductions of Dr. Schett.
Thank you, Mohit. Well, this is a real treat for us to have Dr. Schett with us today. It's a privilege to welcome him. We wish we could take him out for virtual dinner tonight, but it's difficult. So Georg did his early training in Innsbruck, Austria, and then went on to have a very successful career path through Vienna, and then in 2006 moved to Erlangen-Nurnberg, to the Friedrich-Alexander University, which was founded in 1742, so slightly older than the University of Toronto. And Georg is currently the professor of medicine there and head of the Department of Rheumatology and Immunology in Erlangen. And I must say, from just on a personal note, Georg, I think, embodies, in my mind, what is really exciting and innovative about translational research. So Georg really combines the best of cutting-edge basic science with clinically important questions, and he has addressed everything from central nervous system perception of the brain to scleroderma to spondyloarthritis, and he's really been a leader in not only in EULAR but the global rheumatology community. So Georg, it's really a privilege to have you joining us today. Thank you, and I'll pass it over to you.
Yeah, thank you, Rob, and thank you, Mohit, for the kind introduction. It's an honor for me to join the seminar series of your institution, and I think it's a great idea to do this, and I hope some of you will have time to listen to this series. And we discussed a little bit what I should present, and we agreed that would be interesting to speak a little bit about some new insights in the communication between the intestine and the joints. And this small lecture is entitled Barrier Function and Arthritis, and reflects a little bit the clinical scenario that sometimes gut and joint disease coincidence, particularly in spondyloarthritis. In this lecture, I will not talk much about spondyloarthritis, but I want to share with you some concepts how we might understand that intestinal disease is linked to joint disease, and share with you some new data which came out this year and maybe of interest for you. So this is just the first slide. It shows you a graphical depiction of the intestine with the crypts indicated in the left, and these crypts are actually a natural, very probably the most important barrier of the body, because it separates the sterile body from a very unsterile inner environment, which is full of bacteria. And as you see, that these crypts are decorated by epithelial cells, and these epithelial cells are connected with tight junctions. So this tight junction concept is very important, that we don't get sepsis all the time when we do our natural digestion. And it's one of the barrier functions, not the only barrier function of the gut. So these tight junctions are composed of protein complexes connecting epithelial cells tightly. And these, one of the most important proteins are occludins and also zonulin. Better said, ZO1. Naturally, these, in what is depicted in one, these intact tight junctions prevent bacteria to enter the bloodstream. What is important that there is a gradual turnover of tight junctions, and this is regulated by proteins like zonulin. Zonulin is actually a similar molecule like the cholera toxin, which explains why cholera is that effective to destroy barrier function. But zonulin is also produced by the body itself to allow a gradual turnover of tight junction. And zonulin particularly is very effective to disrupt tight junction. So whenever zonulin is high, you have an altered intestinal barrier function, and and the cleavage because of the cleavage of tight junctions. So this is indicated here in a small experiment. You may have seen Thomas Papp last week speaking. When you want to look at epithelial barrier or any kind of barrier, you basically can do a very simple experiment. You plate cells on a membrane and measure electrical resistance. So whenever you have a functional cell layer, in this case an epithelial cell layer, these are CACO2 cells, which are intestinal epithelial cells, they basically provide a resistance against electrical currents when they are intact. And what you can see when you incubate such cultures with zonulin agonists, you basically effectively decrease electrical resistance, which means that zonulin is very effective to cleave the tight junctions between the cells, allow again the electrical current to flow through and damage epithelial barrier function. So why is this important? And I want to start with some human data. And here you can see at in the left side, you can see healthy individuals as the white circles, and then pre-rheumatoid arthritis patients as the black squares. And you see here the zonulin level, and you will easily see that zonulin levels are already obviously increased in pre-rheumatoid arthritis. So it's a very early event, suggesting that impaired barrier function might precede the onset of rheumatoid arthritis. These are individuals with ACPA positivity but no swollen joint. And then when you look at those developing rheumatoid arthritis later, which is the minority, of course, and those staying in the autoimmune phase, you can see that zonulin levels in the middle are higher in patients progressing to rheumatoid arthritis. And you can make a small Kaplan-Meier curve, and you can see that those with low zonulin level, indicating that barrier function is fine, have a lower risk to progress to rheumatoid arthritis as compared to those patients who are ACPA positive and have high zonulin level, indicating impaired barrier function. So that suggests that there is something going on probably before the onset of arthritis, and a second hit, if you want, might be that barrier function disruption occurs at the early stage of the disease. And what we also did, we had the opportunity to get colon biopsies from patients with new onset rheumatoid arthritis. So they were not pre-RA, they were just at onset without any treatment. And as compared to controls, healthy controls, we could observe that occludin and claudin, which are typical intestinal tight junction proteins, are downregulated at the onset of the disease. And also, when you feed these individuals with lactulose, which is an artificial sugar normally not resorbed by the intestine, used as an artificial sweetener, you can see that there is an increased penetration of lactulose into the blood, suggesting that that's a functional test for impaired barrier function happening very early in the onset of rheumatoid arthritis. So obviously you cannot, you can only do limited experiments in humans, but you can also set up a model of experimental arthritis, in this case collagen-induced arthritis, which probably the most used model of inflammatory arthritis. And what you see is here the zonulin level and a red dashed line which indicates the disease onset. And you can see that zonulin levels actually indeed increase before the onset of the clinical phase of arthritis. And at the same time, during this upregulation of zonulin, the epithelial tight junction, in this case ZO1 and also occludin, are actually gradually downregulated and low at onset of the disease. Again, mimicking the picture what you see, we saw in humans, that at onset of arthritis you have a shutdown of the epithelial barrier in in the intestine. So this is mentioned before, so you can test functionally the leaky gut either by in any case by use of non-resorptive sugars, and in this case sucralose was used, and usually sucralose is not actually entering the blood, and day 24 after immunization in the mouse, you don't see an increase of sucralose. But then, and again, before the onset of the disease, you see an increase of sucralose, indicating impaired barrier function, which then gradually increases during the clinical phase of arthritis, in the collagen-induced arthritis model. This is a little bit difficult to see because it's quite dark. It's an immunofluorescence, but basically what it should show, you see some more green dots in the post-immunization phase, day 25 to day 50, which are indicating neutrophils, and you can see also the quantification at the left side. Basically, what it shows that that this impaired barrier function is flanked by a subclinical intestinal inflammation, here indicated by neutrophils, which are entering the lamina propria, and leading to a kind of a subclinical, if you want, colitis, which is preceding the onset of the arthritis phase. So this is quite interesting, we thought, and one would think that there is some link between the gut and the joints, and that's why also I choose this title. And so what we wanted to know, whether really the cells in the intestine, primed immune cells, are going into the joints, which is symbolized here. And to basically look at this, one would actually mark these cells like this colorful umbrella among the many cells in the joints, and look at spot actually marked cells, which are marked because they were coming from the intestine, and this was done by a trick, which is called which is one way to do that is use KD mice. KD mice actually are genetically engineered mice which photoconvert after UV light exposure. So what we did is, we did a first immunization, induced arthritis, did a second immunization, and shortly after the second immunization, you get onset of the disease. But before the onset of the disease, we actually made a targeted UV irradiation of the intestine, meaning that at the local level, you photoconvert cells. And then check after the onset of arthritis where the photoconverted cells, which are in the gut, go into which organ they go. And basically, the results are here. What you see here is a quantification of the photoconverted cells. So basically, in the KD control, you see no photoconverted cells, which is a no-brainer. But what you can see that in the secondary lymphatic organs, like the mesenteric lymph nodes and the spleen, but also in the synovial tissue, even more so, you see a presence of photoconverted cells after the start of arthritis. And actually it's a mixed population, but there is a substantial number of T cells obviously going from the gut into the joint, suggesting that there's truly a shuttling of immune cells from the intestine, which is obviously changed because barrier function changed into the joints. So can we tackle this? And there is actually there are ways to inhibit zonulin. There are zonulin antagonists developed, which are tested for treatment of celiac disease, and one of them is used here. And what we did is actually we did an organoid of the gut, which you see here in the light microscopy, and when you basically use Lucifer yellow cannot, which is a dye, cannot enter this organoid, as you see in the control. But when you incubate this organoid with fecal supernatants from mice-induced with collagen arthritis, you can see that the dye can really penetrate into the organoid, suggesting that there is an impaired barrier function in this organoid, which is of course consisting to a large extent of epithelial cells. And then when you block zonulin, actually you can recover this barrier function, which shows very nicely that you can truly influence barrier function pharmacologically. And this is what we have done. We exposed the mice just shortly before the onset of arthritis with the zonulin antagonist. And what you can see here in the black curve as compared to the white curve, there is it does not protect from arthritis, but it actually delays the onset of the disease. Even this short period of intervention delays the onset of the disease, which is quite interesting, that you can affect arthritis by something which is targeting actually the intestine. And bottom line, when you have less arthritis, what you always see that you have less damage. So maintained bone architecture, maintained bone mass, and the lower level of destruction in the joints, lower level of osteoclast, which is a consequence of less inflammation, I would say, but no direct effect of zonulin on bone remodeling. So obviously the interesting experience then, do you really also interfere with the migration of cells from the gut to the joints? And this is what you do when you see the dark bars here. You can see that zonulin antagonist very effectively blocks the migration of intestinal bone cells into the secondary lymphatic organs, but also into the synovial tissue, suggesting that the effect of this intervention is mostly based on impairment of shuttling of cells to the target organ. This you can do also in other ways. You can, for instance, restore epithelial barrier function by intestinal cannabinoid agonists. So that's probably also interesting for Canada, because I think you have liberalized cannabis in Canada. So when you basically treat with a cannabinoid 1 receptor agonist, in this case RCEA, you can see that you block very effectively the increase of epithelial barrier dysfunction. And also, again, very similar to zonulin, you inhibit arthritis or delay the onset of arthritis and make arthritis more less severe, and also decrease actually zonulin levels, which is a surrogate for epithelial barrier dysfunction. So these are all pharmacological agents, but obviously you would wonder whether diet would affect this. And here we focused on the Stone Age diet, because the Stone Age diet is actually very rich in fibers. It's indicated here with a lot of nuts and fruits and vegetables. And there are a few papers on that high fiber diet might influence inflammation, which are summarized in this review. And there were 7 studies identified in this meta-analysis, and 6 studies actually showed that high fiber diet intake reduced inflammation as measured by C-reactive protein by 25 to over 50%. Which is quite interesting. So what is the principle of this concept? Fibers are not digested cannot be digested by our own cells. You need actually fermentation by gut bacteria to digest fibers, and the products are short chain fatty acid, here indicated at acetate, propionate, and butyrate. And when you here is a murine experiment. When you feed actually mice with a high fiber diet, the same would happen actually in humans, that you increase short chain fatty acid concentration. So C2 is acetate, C3 is propionate, C4 is butyrate, and you can easily see that all of them are increased when you put mice on a high fiber diet. So what is actually the products are the short chain fatty acids. And when you do this and you use, for instance, a short chain fatty acid, you can do that also with high fiber diet. I didn't show it here, but when you use, for instance, butyrate, you can effectively restore epithelial barrier function, which is inhibited by arthritis. As you see, control CRA has the biggest leak of dextran into the blood, which is actually inhibited by butyrate. And also in line, butyrate effectively inhibits the severity of arthritis and also delays the onset of the disease. So we did some experiments in humans where we actually produced high fiber biscuits based on the recipe we found optimal in the animal experiment, and put patients with rheumatoid arthritis on a high fiber diet for 4 weeks. And what you see that what happens, and this is probably the most important part of this slide, is that actually zonulin levels really go down. So in a way, it reflects very much what we saw in the mouse, that whenever you are increasing fibers and short-chain fatty acids, you also affect gastrointestinal barrier function. And in this study, we also looked for readouts, clinical readouts, for instance, health assessment questionnaire, and these things also went down in this study. The effect of the basis of it is probably very much also linked to very fast changes in the microbiome of these patients. So here we did a microbiome analysis in these high fiber diet treated patients, and what is quite interesting that in the high fiber diet that you had as compared to the low fiber diet, you had lower prevalence of Prevotella, Ruminococcus, and Akkermansia, for showing some of them which have been indicated to be important for the development of rheumatoid arthritis or spondyloarthritis. So we think that the early effects of high fiber diet are predominantly changing microbiota and changing actually then the fermentation of dietary fibers and the levels of short chain fatty acids. So in summary, what I wanted to share with you today is first, there is actually obviously a very early decrease of gastrointestinal barrier dysfunction in both experimental and human arthritis, and we think that that might be one of the reasons precipitating the actual onset of the disease, the clinical disease. Then there is a very interesting translocation of gut-borne immune cells to the joints in the context of GI barrier dysfunction. We think that it's possible to restore GI barrier dysfunction by several different approaches. The easiest one is probably diet, but there are also other more pharmacological and more selective approaches, and that allows to mitigate clinical arthritis. And it's probably the link why some of the diets are always considered to have some effects in rheumatoid arthritis and other forms of inflammatory joint disease. And finally, fermentation of fibers by the gut microbiota leads to production of short-chain fatty acids, and they are obviously affecting barrier function and therefore the severity of arthritis. And the last slide is a thank to the group who worked on the project. Mario Zeiss led the team. He's a very talented PhD. And Narges Tajik, a PhD student, was the seminal person in doing the experiment, and with help of several others. So thanks for the attention, and I'm open to questions.
Thank you, George. That was a wonderful overview. I'll actually just start by saying, and actually just a reminder to the audience as well, please don't forget to post your questions on the question and answer tab on the Zoom link. George, it was a great overview, but I wanted to actually talk about obesity. So how does obesity sort of drives the epithelial function or the migration of cells in the overall gut microbiome? Is there any indication of some stuff which you've already done?
Yeah, first, thank you for this important question, and I think obesity changed the game substantially. Obesity creates a pro-inflammatory state first, which is probably mediated by, or at least partly mediated by changes in the gut microbiota, as you know, when you, for instance, give a high-fat diet to animals, you fundamentally change gut microbiota, and in a way, in a negative way, that you basically decrease short-chain fatty acid production. So the overall metabolome of gastrointestinal bacteria in obese patients is different, and it's a more pro-inflammatory state. What is quite interesting that that in this short meta-analysis I showed you, there was in one study also cited where the high fiber diet did not work, and that was actually obesity. The patients were obese. So I think obesity in itself actually limits the action of high fiber diet, and because it generally presents a pro-inflammatory state. And I think the pro-inflammatory state in obesity is not only a gastrointestinal piece; it's also, of course, a piece related to the increased adipose tissue and increased macrophage infiltration in adipose tissue, and therefore generally higher acute phase response. So in a way, to answer your question, or what would be probably interesting, first reduce weight and then use the high fiber diet.
Right.
The right approach rather than do the opposite.
Wonderful.
Georg, I had a question on IL-17 inhibitors. So it was a bit of a surprise, I think. Well, my GI friends say it wasn't a surprise. They already knew that they expected secukinumab wouldn't work in Crohn's disease. But my question is, in the context of this discussion today, well, a couple of things. I mean, to what extent the zonulin-occludin network is IL-17 dependent? And then really a secondary question is, since we have not seen using an IL-17 inhibitors like ixekizumab or secukinumab in SPA patients has not led to an unexpected flare rate of sort of subclinical IBD. So I wonder what your thoughts were on that.
Yeah. So I can only speculate. First, when we look at these kind of experimental models, we see that apart from neutrophils, there is also a increased infiltration of Th17 cells in the gut. So that would mean that IL-17 is part of the pro-inflammatory state in the gut. But that's animal. And as we know that IL-17 blockade in itself is not very successful to restoring epithelial barrier. So in humans, we think that 17 might have some barrier or some epithelial effects which are probably helpful to mount psoriasis, but if you block them, you will not only decrease the epithelial function or hyperfunction in the dermis, but also in the gut. So in a way, what we see that there is a link between, I would think there is don't know whether there's a causal link of if IL-17 precipitates zonulin. But we see at least an increase of an IL-17, would say, signature in the early phases of the onset of arthritis. I always thought that if IL-17 inhibition has a role in rheumatoid arthritis, it might have it in the very early stages when there is this kind of gut joint link, but this has not been studied because all the studies were done in established disease so far. To your question, why we do not see so much colitis, you would say, in a AS population or in a PSA population when treated with anti-IL-17, I have no good answer, I have to say. I think there's some certain redundancy, and I'm always thinking that, you know, that the 17 is probably not a super critical molecule for the barrier maintenance in the gut. But it is adding to it. And if you basically decrease the barrier by non-steroidals, and then the 17 inhibition may add to precipitate in a prone environment to colitis. So I think it's not it's not a one-to-one show between 17 and epithelial barrier in the gut. I would think, because that's what the clinical data show. You know, otherwise you would think 25% you would trigger a colitis, because the genetics, as you know, are similar in AS and Crohn's disease, and you would say, well, that's already a prone individual, and at the end you would have a much higher rate of Crohn's or kind of colitis in this population, but you don't see it. So there must be other factors which are adding to it.
Right. Thank you.
You're welcome.
So George, next question is from Dr. Starley Lively. She's asking, is it the weight of obesity causing the pro-inflammatory milieu, or the poor nutrient diet? That is, do people of healthy weight with low fiber diets show similar inflammatory states in the gut?
Yeah, that's what is thought actually. Definitely a high fat diet is usually low in fibers and would actually not allow to produce a large quantity of short chain fatty acids, and creates a pro-inflammatory state in the gut with an increased barrier dysfunction. So that's one piece, I think, of the obesity story. But as I said, it's not the only piece, as we know that there is. We know very well that in fat tissue is metabolically active and is a strong producer of inflammatory mediators. Among them, by the way, IL-6, and leading to increased CRP. So I think obesity is a process which has, of course, to do with the nutrition and the effect on the metabolome of the gastrointestinal and bacteria. But it's also over the time, it's also a process that is leading to a internal pro-inflammatory state.
Thank you.
Georg, I had a question on the balance, sort of the balance between the pathogen or even the gut commensal versus the host defense. So in the collagen-induced arthritis model, where you're actually seeing altered barrier function before the onset of arthritis, that would seem to argue that the fundamental problem is barrier function. The particular characteristics of the gut microbial population may be quite secondary. It's not and yet we have a literature, as you mentioned, Prevotella, Akkermansia, that argues for a dysbiosis. Now, they're obviously not distinct questions, but do you think on balance the literature favors the primacy of the barrier function over any distinct pathogenic microbe?
No, I'm not a big fan of a particular microbe causing all the problem. I think these are just signature microbes which show a pattern of a different metabolome. In fact, Rob, the first changes what we observed when inducing collagen arthritis were actually microbial changes after the first immunization. So what we think that the microbial changes precede actually the changes in the short chain fatty acid, which would make sense because the diet was not changed, so what we think is that the immunization itself leads to a change in the pattern of bacteria, shifting it to a situation where you produce lower short chain fatty acid, and that is allowing basically that the stronger cleavage of tight junctions and higher zonulin levels. So I think one of the first steps, what happens is indeed the microbial dysbiosis, and I think it's a more broad mechanism, not just that a few moles are basically doing all the job. So what I think.
George, the next question is from an anonymous attendee. Thank you for your interesting talk. Maybe I missed it, but does the gene expression profile of the gut cells also change with high fiber diets that quickly?
Yes, so it is changing rather quickly. Within, I would say, a week, you can say that we did only this experiment in the mouse, of course, but you can see that the high fiber diet effect on the epithelial gene expression, especially, for instance, the expression of tight junctions is working within a few days. So that's probably the reason why it works. I mean, I think it's not as said, it's not a direct effect of the fiber. It needs actually the microbial change preceding it, and the production of short chain fatty acids. And then they work, of course, very fast.
Right.
So I think the delay, if you want, the delay is because of the of changes in the microbiome, rather than the effect on the metabolome on the epithelial cell is very fast.
Wonderful. So the next question is by Dr. Nigel Haroon. Thank you, George, for an excellent talk. Always a pleasure to see and hear you. Genetic variants in responding to dietary changes, what are your thoughts around that? Keeping HLA-B27 effects on microbiome in mind.
I don't know the answer, Nigel. I think when I remember the literature that that people looked at this, right, and at B27 transgenic rats and the microbiome, and I think it has changed, but I don't know much more about this. But maybe Rob, you can even better answer that question than me.
I don't think we got a good answer. We actually looked when we were working with class 1 MHC transgenic mice, Georg. We tried to see whether there was actually a different population. There was some suggestion that a B27 transgenic mouse had a very different signature than an A2 and B7, the class 1 control transgenics, but it really got, the more we drilled down on it, the more cloudy it got. So I think it's a complex relationship.
Yeah, I mean, it's an attractive concept that you would say that the microbiome in B27 positive individuals is different from B27 negative ones, and I mean the data from Paris, from Maxime Brébant, I think he showed ruminococcus as to be enriched in ankylosing spondylitis. I remember. I think all these things have to be confirmed, right? I mean, I would be much more comfortable if other groups find the same species to be enriched than if it's a single-celled study. At the end, I think it is much more interesting to look what the bacteria actually do and what is the metabolome of these bacteria in B27 and B27 positive individuals versus negative ones. This would be, I think, a much better hint whether there is a true change in the physiology of the gut, and also look at actually barrier dysfunction, which you can do in humans, yeah, with the resorption of sugars, with sonulin levels. So these things would be very interesting to look in more detail.
So next question is by Leslie. Is there a time frame that is ideal for introduction of high fiber diet for improving barrier function? In other words, is there a point where impaired tight junctions cannot be repaired by introduction of high fiber? So it's basically the time frame.
Yeah, I would think that they can always be repaired because the gut has enormous regeneration capacity, as you know. I think diet has a limited effect in an active disease, because an active disease has a cytokine storm, if you want, with IL-6 and TNF produced by tons of macrophages and neutrophils in the joints. So then it's difficult to compete with a restoration of barrier function. However, what I think is very important, that after effective treatment, to maintain treatment or to delay the onset of the disease in the very early phase of the disease. There, I think the diet matters, and high fiber diet would be probably something as a adjuvant therapy. It's not an anti-inflammatory. The strength of the inflammatory action, I wouldn't think it's comparable with a TNF blocker or an IL-6 blocker or IL-17 blocker, but I think it has an additive role, and especially I think it has probably a role in the phases where you can control the disease with an anti-cytokine agent, and then you want to actually have a kind of a step out strategy. And yeah, I mean, one of the step out strategies not only to stop smoking, but is also probably to use a high fiber diet as a kind of an adjuvant.
Great. So next question is by M. Bell. Could you comment on the role of probiotics in gut permeability?
Yes, well, probiotics have always been considered to restore permeability or restore actually barrier function. I think the data are diverse, and I think it's not. I would personally think it's not that easy to change the metabolome with a simple probiotic. I think a more solid change in nutrition is probably much more effective than a probiotic in itself. But people always like, have a drug they can swallow and. However, I mean, I should say that in the study we did, in the human study, we did not ask the patient to change their diet, their usual way to eat. They were just they got an addition of a high fiber diet, and that was sufficient to at least change the markers of epithelial barrier function. So that gives the idea that even at least in a non-obese situation, a smaller change, an add-on of fibers could lead to sufficient change of the metabolome of the gut to reach an effect. But the probiotics, I mean, the probiotic stuff is not an easy one, I would say, and probably is often not enough to do a sufficient change of the metabolome.
Actually, a follow-up of that is from a question from Dr. Ali Mobashiri. Beyond fiber itself, how could intermediary metabolites such as butyrate contribute to metabolic and epigenetic modification in the gut, which impacts on inflammation and the microbiome?
Well, it might be not it might be not the only effect of short-chain fatty acid to work on epithelial cells, and there is as these metabolites are easy to penetrate cells, they obviously also affect. They don't stay in the gut. They also affect the whole body, and there is good literature that, for instance, regulatory T cell activity is influenced by propionate and butyrate, and I think it's a field which is developing. Some of the effects, for instance, the effect of the short-chain fatty acid on the epithelial cells are mediated by receptors, GPR receptors. Others are more, other effects are more changing the metabolism of immune cells, especially the work on, especially the data on regulatory T cells suggests that there is a more fundamental metabolic priming of these immune cells by short-chain fatty acid, pushing them in general to a more anti-inflammatory phenotype. Yeah? And what are the products? I mean, itaconate is is probably one of the metabolites which are influenced by short-chain fatty acids in immune cells.
Thank you. Actually, George, just to follow up that, because we had quite a bit of discussion around obesity and fiber intake, but what about if a person is lean?
Lean?
Yes.
Skinny.
Lean and arthritic.
Yes, absolutely. Because how does that actually affect the overall inflammatory cascade? Is the migration of the cells is reduced in those? The cytokine rush is probably reduced in those patients. Have you done studies where you've compared, say, animals who would probably be fed with a lean diet as opposed to feeding them with a high-fat diet?
So you mean low-calorie diet or?
Low-calorie diet.
Yeah, I see. Well, that we have not done. In general, we have not compared this. I would think a low-calorie diet would not necessarily change would not necessarily increase short-chain fatty acids because short-chain fatty acids are really a product of fibers. So if you do a low-calorie diet, which is not high fiber rich, you would not necessarily increase short-chain fatty acids. I mean, it's quite, all the data suggests that I mean, lean people have probably a milder course of the disease and are less susceptible. I think that is not always an effect of the fiber intake. It's also an effect of the fat tissue mass you acquire. And if you have not much fatty tissue, adipose tissue, you may just not have a systemic level of inflammation, which is important. I mean, I think also spondyloarthritis, but also especially rheumatoid arthritis is a very systemic disease, and the threshold of inflammation, I think, is very important, deciding about the severity of the disease. So if you have per se a high threshold of inflammatory mediator, which you have in an obese state, you would have much more pronounced disease. I mean, also when you look, for instance, when you look at elderly onset rheumatoid arthritis, which is usually seronegative, the typical feature is they have very high CRP, a quite acute onset, high CRP, involvement of large joints. And one idea or concept behind that could be that these individuals, they just have a much higher fat mass, because the older you are, the more fat, less muscle you have, unless you train. But in the average, it's like that. And that is, I think, just shifting it very much to a pro-inflammatory state. And the lean is exactly the opposite. So I think the obesity arthritis story is not only a short-chain fatty acid gut story. That's what I want to say.
Georg, do you think that our current paradigm of treating early rheumatoid arthritis first with NSAIDs before we finally get to DMARDs and biologics is counterproductive? Like, we are by giving non-selective COX-1, COX-2 inhibitors, are we actually exacerbating the dysfunctional barrier?
Yeah, I think they're not good. I mean, I think in rheumatoid, in our hands, they don't have much role on non-steroidals, and I would definitely not be stimulated to give non-steroidals at the onset of arthritis. I think they can just worsen it. I think, as you know, they work in enthesial disease, but on the other hand, they always, I think, affect barrier function. Whenever you use non-steroidals, you will affect barrier function of the intestine, and maybe that's, I mean, if you do a short course, that's probably okay. Your anti-inflammatory effect will be outweigh the negative effect on the intestine. But if you do it for I think a longer time then, or more regular use, I think that's counterproductive. Because they are one of the strongest agents to downregulate epithelial barriers.
Yeah.
George, next question is by Dr. Soumya Viswanathan. This is an excellent talk. Thank you. I was wondering, we see similar barrier function of macrophages in the synovial lining. these are disrupted in osteoarthritis. Did you look at the synovial lining in your models? Also, is the barrier function of macrophages disrupted there, which allows for entry of circulating immune cells?
So we did not look at that, but I would bet that that barrier function in the synovial lining is disrupted, because this is required to mount arthritis. Whenever you have arthritis, your macrophage barrier will be deregulated. Otherwise, you cannot get arthritis. However, what we know is actually whether we can influence the joint barrier with zonulin, and we can't. So zonulin antagonists are really specific for the gut, so they work in the gut, in the epithelial barrier, but they don't work on the macrophage barrier. So the molecular pattern of the macrophage barrier in the joint is not based on ZO1 and zonulin. So you have to answer, short answer, yes, you will affect barrier because arthritis affects barrier in the joint, but the barrier in the joint is a fundamentally different barrier than in the gut. And you can have specific approaches targeting the gut barrier, which are not working in the joint barrier. So that's important, because if you would say that you restore the joint barrier, you would say, well, that's why they are resistant to arthritis, or they get arthritis less. But that's really an approach which really affects the gut specifically and not the joint.
Rob?
I think that's, any other questions in the queue?
That's great. George, we've had a fantastic lecture and great overview and great discussion. Thank you so much for your time. And also, I want to remind everyone, next week, please join us for our lecture number 6 for the Arthritis Program web seminar series. The lecture is going to be by Dr. Frank Berry from University of Ireland in Galway on stem cell applications in joint development, disease, and repair. Thank you, George, and see you everyone next week.
Good to
Thank
see
you very much for the invitation.
you. Stay well. Bye-bye.
Bye-bye.